Welcome to integration. The last video we call has to do with differentiation. And integration is the reverse of differentiation. It's very easy. It's like doing the opposite of what you were doing when you were differentiating. But before we get into some examples in integration, let's look at some standard integrals. It's important to remember this. Anytime you are asked to integrate, just know that's the value of the integral. So what are some of these? I'm going to give them to you, some couple of them. Let's assume I have sine x dx. And the question says integrate this. What's the standard integral for sine x? It is minus cos x plus c. Now in integration, we introduce what we call an arbitrary constant and which we represent as c. Yeah, remember when you differentiate, sometimes you differentiate constants. And we don't know that constant, so we represent it with the arbitrary constant c. If we provided with some information, we can be able to look for that c or constant. Don't forget, when you differentiate sine x, it is cos x. But when you integrate sine x, it is minus cos x. So that's why I say it's the reverse. Let's go to number 2. Now I have integral cos x dx. Can you remember when you differentiate cos x what you have? If you differentiate cos x, you're going to have minus sine x. But that's not so with integration. It's the reverse. If you integrate cos x, you're going to have sine x plus c. So you see why we say it is the reverse. Again, remember this, very easy. These are standard integrals. Don't forget them. Let's assume I have sec square x dx. Now, if I integrate this, what will I have? It's going to be tan x plus c. Again, it's very easy. Let's go to number 4. I'm integrating the exponential function. What will it be? It will not change. It will still be what it is. Let's try another one. If I'm integrating 1 divide x, what would this be? Anytime you have the division sign, it becomes in whatever is at the numerator plus your constant. Very easy, right? Let's try one more. If I have a raised to power x to x. Now here the a is a constant. So what will it be? It's going to be a raised to power x divide in a plus your arbitrary constant. Okay, I think I still have one more to go. Let's assume you're integrating a constant. Let's say 2 dx. Now this is a constant. What do? It's going to be 2x plus c. Why? Because it's a constant. But now it's quite different from this. Let me introduce this. Supposing I'm having 2 raised to power x dx, which is like question number 6. The difference between these 3 is that this has no x attached to it as has a power. When in number 8 and 6 are alike, the a can be treated as the constant 2 here. Now it has raised to power x dx. Whatever you have here will be the same result you have in number 6. It will not change. It will simply be 2 raised to power x divide in 2 plus your arbitrary constant. Okay, let's look at these questions. I have 3 questions here, and I'm asked to integrate them. Very easy. Let's look at number 1, integral x raised to the power 5 dx. What will be the value of this? Remember, integration is the increase of power. It means you're going to increase the power by 1 and divide by the increase. Always remember your arbitrary constant, and so this will give you x raised to the power 6 divide 6 plus c. So that's the value. Now what about this next question? Again, we're going to increase the power, so it's going to be 5 x raised to the power 5 divide 5. So the increase of this power is what you use to divide. So since I increase the power to 5, I'll divide by the 5 minus 8 x. I'm going to increase the power of this to 4 since it's 3, and then I'll divide by the 4 minus 6. This is x raised to the power 2. I'm going to increase the power by 1, which is 3, and divide by the 3 plus 2. I'm going to increase the power. So this is already 1, so 1 plus 1 is 2, and then divide by the 2 plus. Now check out this. This is a constant. If you integrate a constant, it's going to be 1x. But in maths, you don't write a 1 as the coefficient, then plus your arbitrary constant, c. This can divide this, so I'm left with x raised to the power 5. This can divide this, I'm left with 2x raised to power 4. This can divide this. I'm left with 2x raised to power 3. This can divide this. I'm left with x raised to power 2 plus x plus c. That's the solution to the question. Okay, so let's move on to the last one. In the case of this, increase of power, increase the power here, x raised to power 3 divided by the 3 minus 4x, increase the power, s raised to power 2 divide 2 minus this a constant, so you introduce the x plus c. This can divide and you're left with 2 here, so this becomes 2x raised to power 3. This can divide and you're left with 2 here, and this becomes minus 2x raised to power 2 minus 3x plus your arbitrary constant c. That's the solution to the question. Now let's look at other questions where we are to integrate. We are to find the integrals of the number one question there, integral for x raised to power x dx. Now, what will be the result of this? See, just looking at this question, you'll be thinking it's one big deal, but it is not. The solution is simply for e raised to power x, an exponential function, plus your arbitrary constant. That is all. Very easy. Now look at the next question. Integral 3 divide x dx. Now remember the standard integral for 1 divide x, it is in x. So this 3 divide x will simply be 3 in x plus your arbitrary constant. That's all. Very easy. Look at number 3. Integral 7 sine x dx. Now we are to integrate this. Now I can bring out the constant here and just integrate sine x. It's the same thing. Remember, the standard integral for sine x, if you integrate sine x, is minus cos x. So this will be minus the 7 cos x plus your arbitrary constant. So that's the solution to the question. Now look at this number 4 question. Integral x raised to power 1 over 3 or 1 divided 3 dx. Now, remember what integration is, increase of power. So this will be x raised to power 1 over 3 plus 1. We'll always increase with 1. Divide 1 over 3 plus 1. That's the same thing then, plus your arbitrary constant. If you solve this as a fraction, it's going to be 1/3, which is the same thing as 4 divided 3. And that's what you also have at the denominator, plus your arbitrary constant. And this, to simplify, is the same thing as 3 divided 4, x raised to power 4 divided 3, plus your arbitrary constant. If you wonder what I did here, let me show you using the space here. This is the same thing as x raised to power 4 divided 3. This is division sign, divide 4 divided 3. So this division sign is this division sign. Now you cannot simplify except you take away the division sign, change it to multiplication. And if that happens, you take the inverse of 4 over 3, and that becomes 3. So when 3 multiplies this, it's going to be 3x raised to power 4 divided 3 divided 4. So that's how we call this result, just in case you are wondering how. Now let's go to number 5. Now look at number 5, integral x raised to power minus 2 dx. Same thing. You're going to increase the power by 1 and divide with what you have there in the power, plus your arbitrary constant. This will give you minus 2 plus 1, it's minus 1, divide minus 1 plus c, which is the same thing as minus x raised to power minus 1 plus your arbitrary constant. Now let's look at more integral questions. We are advancing now, going from simple to complex. But again, no matter how complex the integration is, it's still easy to solve. Look at this question. Integrate 4x cos and bracket x squared dx. Now when you look at this question, you'll be confused. What do I do? It's still very easy. All you need to integrate is the trig function, which is cos, and whatever you have here. So I'm going to have my 4x will be there. Don't touch it. Then if you integrate cos, remember what it is? Integration of cos is sine. So you're going to have sine. Your x squared will stay there. But this, because it's square, you're going to differentiate what you have in the brackets. And if you differentiate it, it's 2x. Then you divide by 2x plus your arbitrary constant. That's the solution to the question. Now you can decide to simplify, make it easy. This 2 will cancel this, and this x will cancel this x. But this x cannot cancel this x, so only the one outside. So I'll be left with 2 sine x squared plus my arbitrary constant. Okay, let's look at the second one. Integrates x sine x squared, the x squared in brackets, the now again, you don't touch the x since it's outside, but you integrate sine. Remember, if you integrate sine, it's minus cos, so the minus will be here. Don't put it here. Remember, I said so. So put it outside, and then you put your cos, and then you have x squared. But don't forget to differentiate the x squared in brackets, which is 2x, and then your arbitrary constant. You can decide to simplify this so that it becomes minus cos x squared divided by 2 plus your arbitrary constant. That's the solution to the question. Now this is another question. Integrate in bracket 3x minus 4 all raised to the power 4. When you see a question like this, you'll be wondering, what do I do? Integration is increase of power. So what you do is just increase the power. Write everything you have in the brackets. Don't touch anything. Increase the power. So 4 plus 1, that's raised to the power 5, plus your arbitrary constant. But there's something else you will do. Divide that 5, then multiply. You see, you differentiate the expression in the bracket. If you differentiate 3x minus 4, it's 3. So you multiply by 3. Remember, if you differentiate a constant, it's 0. If you differentiate 3x, it's 3. So sometimes you differentiate while integrating. You do that when you have expressions in bracket like this and like this one we saw. Remember, we differentiated x squared to be 2x. And when you differentiate, whatever you have, put them as a denominator under integration. And so this will be 3x minus 4 raised to the power 5 divided 15 plus your arbitrary constant. That's the solution to the work. Easy peasy. Now I want to do one work that looks like number 3 so that we'll get the whole thing clearly. Again, everything in the bracket, don't touch anything, write them, put it there, increase the power by 1. This is power 3. If you increase it, it becomes power 4 plus your arbitrary constant. And then you divide by the power 4. You differentiate what you have in the bracket, and that's 10. So this gives you 10x plus 2 all in brackets raised to the power 4 divide 40 plus your arbitrary constant. Now, one more example. This will be the last example. The principle can help you to solve any question in integration. Here, you see the x is having a coefficient of 4. So what do you do to integrate this? Remember, if you integrate cos, it's sine. And then you put your 4x there plus c. Divide, anytime you have a coefficient, then you differentiate. If you differentiate 4x, it's going to be 4. So you put it over 4. Divide 4. So that is the solution to the question. Do you have any question? Remember to always put it at the comment section. But I'm going to leave you with this. Integrate e raised to the power 3x minus 1 dx. Now, messing this, you'll be thinking it's difficult, but it's not. Just remember the principle we've been applying, and then you'll get the answer correct. Remember to like, share the video, and subscribe. And if you have any question, put it at the comment section. If there's a topic you want me to solve, please put it there. Thank you for watching. See you in the next video.